Alright, so for factoring quadratics, we're going to start with section 1, lesson 8-7. It says factor ax squared plus bx plus c. In the last lesson, you factored quadratic expressions in the form of ax squared plus bx plus c, where a was equal to 1. On these examples that we're going to be doing in this section, a is not going to be equal to 1. So a is the number or the term in front of x, not the term, the coefficient in front of x squared. So we're just going to go through this example briefly. We're going to go over some key concepts, and then we're going to do some examples. So if they give us the equation 2x squared plus 5x plus 3, and they want us to factor it. First thing we have to realize is we're looking for factors of 6, because that 2 times 3 gives us 6. So we list out the factors of 6. This is what we do in our T-chart. So 1 times 6 equals 6, and 2 times 3 equals 6. And then we write out the sums. So 1 plus 6 equals 7, and 2 plus 3 equals 5. We are looking to add up to equal to the middle term. So that tells us that we're going to be using that 2 and that 3, because they multiply to give us 6 and add to give us 5. So that's the T-chart that we were setting up. So now what we're doing, this is like the box method, but this is actually writing out the box method. So this is another way of finishing out factoring. So they start with 2x squared. That was our first term. Now here they put plus 2x plus 3x. They got the 2 from here and the 3 from here because those are the factors. So what we did is we broke down that 5x to look like 2x plus 3x. And then we just brought down the plus 3. That was our last term. So this is like filling in the holes of our boxes. And now what they did was they took out the greatest common factors. So here, they put the 2x and the 2x squared together. And they put the 3x and the 3 plus 3 together. The reason they did that is because 2x squared and 2x have a greatest common factor of 2x. 3x plus 3 has a greatest common factor of 3. So they grouped the ones together that had factors. So once we pull out that 2x, we're left with x plus 1. Once we pull out that 3, we're left with x plus 1. And then one more time, we take out the greatest common factor. Both of these expressions or both of these terms have x plus 1, so we pull out at x plus 1. And so we're left with 2x plus 3. We can double check this by multiplying it out and doing our box method, but I'm not going to do that. So down here where it says key concepts, you have to remember. Sydney, can you read where it says words?
To factor trinomials of the form ax squared plus bx plus c, find two integers m and p, with the sum of b and the product of ac. Then write ax squared plus bx plus c as ax squared plus mx plus px plus c, and factor by grouping.
It sounds like a lot. Yeah. It's not. This is just another way of doing what we were doing before with the box method. Okay? So look here. If the standard form of our quadratic is ax squared plus bx plus c, a is the number in front of x squared, b is the number in front of x, and c is the constant term at the end. So here, a is equal to what? 5. B is equal to what?
13.
What kind of 13? Negative 13. And here, C is equal to 6. So here it's telling us we're trying to find two integers with a sum of B and a product of AC. So you said that A was 5 and C was 6. The product of AC is 30. So we are trying to find numbers that break down to give us 30, but they need to add to give us what? Negative 13. So negative 10 and negative 3. If we multiply these two together, we get 30, because a negative times a negative is a positive. And if we add these two together, we get negative 13. So that's just factoring. That's another way of doing factoring.